So thank you, Brendan, for being one of the reasons for making this seminar happen. And we are very happy to have you today. So Brendan is going to tell us about abstractions for real people. Brendan, before we get started, I have a question for you.
Uh-huh.
What does compassionate math mean to you?
Oh, good question, Priya. I, in some sense, this talk is part of my answer to that question. I've been thinking for years about the practice of mathematics, and you know how, on one hand, it is sort of this artistic and this sort of academic, this sort of intellectual pursuit, but for me, it's also a way to be involved in making the world better for people, a practice, of, in some sense, an expression of love. And so wrestling with these questions over the last many years, this is sort of a bit of my thinking about where I'm at, and that is that part of compassionate mathematics is a practice of using mathematics in a way that supports other people and lifts it up. And this means we might want to reflect on, well, how do we practice mathematics, and how does mathematics relate to, as we talk about here, real people?
That's very beautiful. Thank you. I will reflect on what you said.
Cool.
Okay. The
Well,
stage
thanks.
is, thank you. The stage is yours.
Cool. And thanks for the lovely introduction. So I'll get right to it. The oops, yeah. So the core point of this talk is quite simple. I put forth that we should reflect again, as I said, on our practice of abstraction, our practice of mathematics. And in this compassionate way, I want to say that it is more compassionate. It supports people and their flourishing when it has these three properties of being accessible, responsive, and pluralist. Um, and then secondary to that, sort of speaking as a category theorist, as a member of an organization that takes category theory as core to its practice. And I know many of this group also, values and practices category theory. I want to say that there is potentially a role for, in particular, category theory to play in this practice of abstraction. So I'll describe sort of abstractly the the setup, the sort of way I see abstraction as realized in the world, and the challenges, the opportunities and the challenges of that. And then I will switch to talking about some of our work at Topos, instantiating it concretely in this project CatColab, and then talking about how uh, using this as an illustration for how category theory helps with this practice. Um, And I think at core, if there's one thing that runs to your mind, it is this question of, in modernity, so much of the way we live, the way we relate to each other, the way we relate to our environment is mediated by these technological systems. And the core question to me is, how do these systems represent what is valuable to us? And can they represent more of what we truly value? And where they can't, what do we do? How do we deal with these boundaries of what these systems can represent? Because of course these systems can only support the things that they can represent, and are blind to anything that they can't. So I'll begin with three stories, just talking about abstraction in the world from three different perspectives. The first goes like this. The International Classification of Disease, ICD, is a worldwide standardized system for classifying diseases that's used in collecting mortality statistics, among other things. So, for example, it's used by the World Health Organization to coordinate between different national health organizations. It's used for people to figure out what's happening in these local contexts death-wise so they can get better public health outcomes. And this quote continues, without a centralized standardized system, that data collected by various offices won't aggregate. But the ICD has highly variable granularity. It has separate categories for accidents falling from playground equipment, falling from a chair, falling from a wheelchair, falling from a bed, falling from a commode. But it only has two categories for falls in the natural world, falling from a cliff and an other fall category that lumps together all other falls, including, in its example, falls from embankments, haystacks, and trees. The ICD is obviously much more interested in recording the kinds of accidents that might befall people in an urban industrial environment than a rural environment. And this quote goes on to describe how um, the different ways this data is collected uh, benefit different people more than others. So in particular, it benefits people in an urban industrial environment more than a rural environment. And this additional attention to the things that matter to particular people is a way that this data collection is not, this ontology is not just simply neutral, uh, but encodes the values and the purposes of the people that use it. The second quote I have comes from Weapons of Math Destruction by Cathy O'Neil. So the context here is that there's a new chancellor of Washington, D.C. public schools. And shortly after their tenure begins, they develop a teacher assessment tool called Impact. And at the end, in this time period, at the end of the 2009-2010 school year, the district simply fired all the teachers whose scores put them in the bottom 2%. Sarah Vysotsky, a fifth grade teacher, didn't seem to have any reason to worry. One evaluation praised her attentiveness to the children. Another called her one of the best teachers I have ever come into contact with. This is evaluation both from parents and from peers and her principals. Yet at the end of the 2010-2011 school year, Vysotsky received a miserable score on her impact evaluation. Her problem was a new scoring system known as value-added modeling, which purported to measure her effectiveness in teaching math and language skills. That score, generated by an algorithm, represented half of her overall evaluation, and it outweighed the positive reviews from school administrators and the community. This left the district with no choice but to fire her. So what's going on is that the this impact scoring system, well, first there's this goal to improve, public school teaching in these low-income districts, which is a commendable goal. And part of the view here is that a good teacher will improve test scores. So this is built into the scoring mechanism. But the challenge is, and what we realize as the story unpacks, is that these numbers are perhaps not that reliable. So Vysotsky is in this context teaching middle school, and the students have come from different primary schools, so different schools or different elementary schools in this country, and there are all sorts of questions to the data. So in the leaving data they have for the previous school has the class average reading proficiency at 5 times the district average. But when she works with these students, she realizes they struggle to, complete basic reading tasks at the 5th grade level. And there are all sorts of incentives. For example, this being the second year, the teachers from the previous year know that their bonuses, not only are their jobs, but there are bonuses too, tied to changes in test scores. And overall, as they unpack this, they note serious irregularities in the change in test score. But nonetheless, they present this data to the school district, and they nonetheless agree that there may be some questions here, but the process is the process, and it was designed fairly, so that the decision that Vysotsky is fired remains in effect. And the overall outcome is not so much that Vysotsky is out of a job. In fact, a few days later, because she is recognized as a good teacher by her peers, she picks up a job in an affluent school district. But we see the move of a good teacher from a place where they want to serve and where they can serve these low-income districts to a context where that she makes less of a difference. So that's the second story about abstraction in society. And the third story I have comes from a different context. It comes from work at the frontier of AI. So these tools like ChatGPT and Claude, for example, that are rapidly reshaping society today. And it comes from Stuart Russell, a professor here in Berkeley, who is really a pioneer in the field, who is a co-author with Norvig of perhaps the standard textbook on AI. So Russell writes, to get an inkling of the fire we're playing with, consider how content selection algorithms function on social media. They directly influence billions of people. Typically, such algorithms are designed to maximize click-through. That is, the probability that the user clicks on presented items. The solution is simply to present items that the user likes to click on, right? Wrong. The solution is to change the user's preference so that they become more predictable. So those are 3 stories. And I want to bring out some common themes in the way I see these stories, and in particular the role of abstraction in in what's going on here. So let me first say what I mean by abstraction. By abstraction, I mean that, a way of describing the world abstracts another way of describing the world when it treats distinct expressions as the same. So, for example, the just the raw assessment of quantity to, there are however many people on the Zoom call. It is an abstract way of describing the individuality that we all have, and is relevant for the purposes, for example, of do we have a large enough Zoom license to make sure we can host everyone who wants to attend? But it doesn't get at the detail of, what are your individual interests, what are your cares, and so on. And so the point is that abstraction is used to focus attention on distinctions relevant to the purpose at hand and make invisible decisions, distinctions that are irrelevant, again, for the purpose at hand. So the thing I want to point out is that while people often think of a practice of abstraction or practice of mathematics as sort of a neutral objective enterprise, abstraction is an inherent act of meaning making. It's done relative to a purpose, and it makes judgments about what is relevant to that purpose. And it can easily forget things that are considered relevant by the people who are represented by these systems. So, for example, if you think about just you're filling out a form on the internet, you're, I don't know, buying something online, or buying an airline ticket, then it asks for your name. But often the systems we use, especially the ones in this English-speaking world, have certain assumptions about what a name is. They assume, names cannot be more than 20 characters. You have a first name and your last name. Those characters are the standard characters of the English alphabet. You can't have things like hyphens. You can't have things like, Arabic script or Chinese characters. You can't have, a tradition where you have two last names or many, many names that are meaningful to you. Um, and so again, what's going on is that there's as an abstraction of a notion of a name, a notion of human identity, and it's making certain assumptions, and these assumptions are relevant to some people, but not relevant to others. And that's, this is to illustrate this point that abstraction does have this meaning making component. It's not neutral to it inherently. So um, within this sort of world abstraction, I want to introduce two terms for the purpose of this talk. One is the way talking about how abstractions frame a view on the world. So I'll simply say that frame is a collection of abstractions assembled to provide language for a particular domain or worldview. Other words you might use are things like a domain-specific language or ontology, or less formally, a worldview, a perspective. Uh, and it could be a sort of personal perspective or sort of a disciplinary perspective. Um, Within frames, the purpose of frame is to describe a worldview, but then within a worldview, you want to describe a particular world. And so I'm going to call this content. So within a frame, content may be asserted as a specific description of a possible world within that frame. So, to go to the stories I told at the beginning, there is a certain framing on like how to think about death, what are the possible causes of death, and then the content is, the death statistics that are produced by, I don't know, the country of Malaysia within this international classification of disease. Um, Another example of a frame is this frame, what does it mean to be a good teacher? And this frame that the DC public schools district adopts is one that has this notion, for example, of test scores as an important aspect of this frame. And then it makes the assertion with this frame that Vysotsky is not a good teacher, something like that. So these frames that we use to navigate the world get quite complex. But I want to point out also that they can start with very simple things. So for example, down here in this bottom right-hand corner, I have this simple frame for causality. And this frame simply says there are these things in the world called events. There are relationships between events where a causal event, that you have a cause effect event that affects an effect event. And these relationships may be positive and negative. So the cause may increase the likelihood of the event or the frequency of the event, or decrease the frequency of the event. And then as an example of content within this frame, I'll use this classical example. There's this event called rain. There's an event observing the grass is wet, and if you observe the event rain, then you believe, or this content asserts that it's more likely that you'll observe that the grass is wet. So a simple frame and a simple assertion of content within that frame. Right. So how does this pertain to our stories? These authors are not just interested in telling, giving the accounts that I gave on the first page, but they're also analyzing these accounts. And I want to point out something that's very interesting to me is that these authors come from very different traditions. So Nguyen is as a philosopher, and coming from this sort of science, technology, society studies perspective, work that is integrated with sociology, and anthropology. O'Neill is a mathematician turned data science turned, whistleblower on the industry in some sense turned journalist. And Russell is, as I mentioned earlier, at the forefront of frontier AI and this work on, moving towards these notions that people think about of agentic intelligence or artificial general intelligence or superintelligence, intelligence that works across all contexts, or these technologies that perform actions across all contexts. And so let me read out these quotes. First, Nguyen says the problem occurs when users of data forget that categories are social inventions created for a purpose. When these classificatory schemes enter an information infrastructure, they become invisible. They become part of the background operating structure of our world. The power of data is vast scalability. The price is context. O'Neill diagnoses in her book this notion of weapon of math destruction and has many examples that follow this pattern. And the overall pattern she asserts is this. There are three elements of weapon of math destruction: opacity, scale, and damage. And Russell here in this passage is reflecting on the practice of AI, and talking, the book is titled Human Compatible, talking about the risks of AI development. And he's reflecting in particular of a practice of or lack of humility in the work by AI scientists. So he says, yet uncertainty in the objective of the AI system was simply ignored. In all the work on utility maximization, goal achievement, cost minimization, and reward maximization, and loss minimization, it is assumed that the utility function, the goal, the cost function, the reward function, and the loss function are known perfectly. We never really examine this fundamental assumption. And so here we see this pattern, which I'll go through via the lens of O'Neill. So the first is that there's an assertion of damage. So this is an assertion that these systems, these abstractions aren't capturing or representing all that is relevant to the people affected by them. So while O'Neill talks about damage, Nguyen talks about the context being a price, and Russell talks about how talks about the uncertainty in the objective, right? So that they've reified or talked about the objective of the system and said that this represents what we care about, and ignored the fact that maybe it doesn't. Maybe there are things that are outside what is represented here that are relevant to the people at hand. So that's damage. The second thing that they talk about is opacity, which is that even if what is valuable to the people is not represented, it's hard to notice this and indeed hard to change it. So Nguyen talks about how these classificatory schemes are invisible. They become part of the background structure. Um, and and Russell talks about how these objective functions are not really examined, right? They're assumed to be known perfectly, and that this is nothing that is not re-examined through the construction of these AI systems, which are then sort of often exported as black boxes to use, for example, in your web browser or something like that. So, and the third element identified here is this notion of scale, that it's not just something has not been represented and that's hard to challenge in some local context, but there's a push to use this across a wide variety of contexts, which impact lots and lots of people in this, this insensitive way. So O'Neill talks about scale, Nguyen also talks about scale, and infrastructure and sort of background operating structure. And Russell talks, is working in this context of these sort of generally intelligent systems that are meant to work, in these promises we hear across every different, in every different setting. You can just go to, ChatGPT and it'll help with your problem. So my diagnosis here is again that what these stories have in common is that the underlying frame fails to represent or capture something important to a community impacted by the use of this frame or this set of abstractions. And this has, long-lasting and widespread and serious human consequences, tackling, serious problems around, in the first case, how we improve public health, how we reduce unnecessary deaths in the world. The second, how do we educate our children? And the third, how do we, this social media context, how do we connect with information that is meaningful to us and connect with other people that are meaningful to us? And and so my response is, well, these people, what it was also striking about this story is that there is no clear bad actor. People are genuinely working, people take an important problem to heart and they're genuinely working to try and improve lives. But something about, I claim that there's the practice abstraction that is ambient in the way we do things in society, um, is impacting the ability to achieve these goals that are shared amongst all parties in these pictures. And my my suggestion is that reflecting on this practice of abstraction, we strive instead for a practice of abstraction with these three properties of accessibility, responsiveness, and pluralism, as I say in the previous slide, or in my first slide. So to unpack this a bit, when I talk about accessibility, I'm talking about a practice of abstraction where people can name the overarching abstract frame. So they can articulate when and why the content expressible in a frame cannot or does not or cannot represent them. And then it's not enough to just be able to articulate, why this frame is constraining for you and not allowing you and your community to live the life that you hope for. It's important that you have agency with respect to that, so you can reshape the frame according to your needs. But then we also have we see, I want to be respectful of the vast benefits of abstraction in constructing a modern world and allow us to do things like we're doing now, coordinating through information technology across the world, through things that have been built through these global supply chains and these very, um, you know, relatively stable political structures. These are all benefits of abstraction. And so we want to retain, the this practice, even as we reshape it. And one potential cost you might point here is that if every local sort of person is able to reshape the frame according to their needs, then you get this fragmentation, and so you don't get these benefits of cooperation and coordination, um, and the material benefits from that. And so the third desiderata here is that, or desideratum here is that while people can reshape, we strive for a practice of abstraction where people can reshape the framework according to their needs. We also need to balance this with a way to work effectively with others who prefer different frames. So there's some sort of coherence or unification even across the respect for context and difference. And so, to use these words again, I suggest we strive for what I'm going to term here an accessible, responsive, and pluralist practice of abstraction. I don't claim that category theorists or mathematicians themselves are, the only people. I don't claim that we have sort of a solution to, these vast human problems that I've led with in these stories. We are not the only players here, but I do think that as custodians of the practice of abstraction in society, basically, we do have a particular role that we can play, something that we alone can contribute. And I think this category theory community has a potential special thing we can contribute within that, right? So I say here that I hope we can consider category theory as a formal study of the process of production of abstractions, and we can in fact offer this to a practice of abstraction in this way. and how this viewpoint of category theory as a formal study of the process of production of abstractions is informed, especially by a categorical logic, sort of a universal algebra viewpoint of category theory that says that we get all these, we get all these logical structures that lie within these ambient sort of doctrines that we can customize to describe very different, many algebraic structures and logical structures in the classical practice. And in the practice of applied category theory, have looked more a lot at these systems languages. Um, but then, so we formally study the way these abstractions are produced, the ways they relate to each other, the ways they can be combined. They can be, abstractions can be taken as sort of seed things to combine to more and more sophisticated abstractions. And I claim that this can respond to this call for an accessible, responsive, and pluralist practice because I'm going to claim that the formality provides an edge into the accessibility. It provides a certain clarity to what's going on. When we talk about, uh, the production, we can talk about being responsive. We can talk about producing and reproducing abstractions according to the needs of the communities they're intended to serve. And by acknowledging that these abstractions are produced in many different ways through many different processes, and yet still relate to each other, we can get at this pluralist way of thinking about abstraction. And indeed, the seminar being the relatorium seminar, it has this aspect too. It takes category theory as this sort of relational practice and this pluralism as a and this relational practice allows this navigation of relation between different sort of abstractions, different mathematical concepts, different worldviews in this pluralistic way. So that's my sort of overall setup and the claims I want to make about the practice of abstraction. Now I'm going to switch modes and talk a bit more about how this is realized within category theory and within a particular project we've got going on at Topos. But before I jump into the second phase, maybe I can just quickly pause and see if anyone has any questions. Is there anything that's not clear people want to clarify? Cool. Um, I'll move on to talking a bit about CatColab then. So CatColab is an open source software platform. You can go to catcolab.org and then pull out this system. And I'm not going to tell you too much about the details, but it is, in my view, sort of a platform for complex systems modeling or a platform for collective sense making via formal interoperable conceptual modeling. So you see here on the left a model of the world, and this is done in a collaborative way. So I say below that this is sort of inspired by things like Google Sheets, SQL, Jupyter, Lean, GitHub. So this vast and sort of cross-cutting set of information technologies that we have. And I don't claim that it replaces any of these, but there are elements that we draw from each of these. So from something like Google Sheets, we draw this sort of collaborative live process of just sort of trying to write down in some slightly structured way an understanding of the world. So I think it's really interesting to note that where we do have problems of, say, collective sense making in, say, an organization like Topos, something like a spreadsheet and a collaborative spreadsheet is one of the first things we turn to make sense of it, whether it's sort of planning an event or negotiating over a budget. It really helps to have these sort of collaborative objects where you can write down your understandings of the world and interrogate them and have these things serve as what is termed a boundary object between people. So to clarify the communication. Uh, there are also, one one thing we want to add to this is, say, some of this functionality or the spirit from relational databases that lets you explicitly talk about your ontology and then how data is realized within that ontology, and then query, with respect to that ontology, migrate between different perspectives. So that's an aspect that's built here into CatColab 2. In Jupyter, we see some aspect of data analysis, of scientific computing, of sort of real serious analysis of the different viewpoints that come up as you represent them in this way. In something like Lean or Proof Assistant, you see not just numerical analysis, but logical reasoning, formal support for logical reasoning about the properties of the world you're trying to describe together. And then in something like a tool like version control, you see attention to the process of production of these models of the world as sort of distributed and collaborative and traceable and accountable. You know who made which assertion and when, and and then you have some way of tracing the not just the object as it is today, this representation as it is today, but how it came to be and from whose perspective it came to be. So this is the goal of the platform. Um, on a more technical level, there are sort of two interesting points I want to make. The first is that the underlying framework is a declarative language based on double categorical logic, and I'll unpack that in the table below in a moment. The second is that this is the practice of programming here is to really have formal mathematical semantics behind everything, to really provide sort of rigor and clarity. So every machine readable statement in the CatColab system has a formal mathematical semantics. Um, and the semantics comes out through these four layers, which have this sort of graded assertion of sort of here's a frame. Now let's assert some content within that frame, but that itself frames some more detailed content and so on. So I'll go through this quickly. I'm not expecting anyone to know double category theory, um, but I want to give a sense of just this sort of layered structure of this modeling practice. So we have these things called doctrines, and you again this term is drawn from standard categorical logic, but the doctrine here ambient is an ambient structured double category. So you might have sort of the plain notion of double category. You might have notions of double category tabulators or Cartesian double categories. We introduce the notion of conjunction and so on. Then within a doctrine, you can specify a theory as a structured double category. And so here we might have theories of, causal loop diagrams, database schemas, stock flow models, Petri nets with links. So causal loop diagrams are this sort of simple theory of causality that I showed earlier. Database schemas are, standard sort of relational database schemas. Stock and flow models are this frame that tries to describe a worldview where things have quantity and things that flow between them. Um, these are commonly used for example, in the systems dynamics tradition in economics. And then we have another example, Petri nets with links, which is as a frame for representing, or a worldview for representing basically like concurrent processes. Then one layer down, we have this notion of model. Um, there is, for examples of this, the particular database schema for the international classification disease, or a particular stock flow model for an SEIV model. So this pandemic or infectious disease transmission model, or a causal loop diagram of something like a cap and trade policy. And then one level below that, we have this notion of an instance. And so you can imagine this example of, well, we have the database schema for the international classification disease, but then we have a database of health outcomes in a particular context according to the schema, say the context being like Nairobi City County. So the layer in particular of sort of frames and content I'm going to focus on is this sort of theory model uh, layer. And going to describe a bit how that is realized in CatColab, but then it's also supported by this sort of meta layer in the doctrine and this more specific layer in this notion of instance. So to give a concrete example, this recapitulates the example you saw 2 slides ago when I just had this screenshot of CatColab in action. So there is a frame represented here through this notion of an atchit, which is just one way of representing a frame in this system. But it simply says that a stock and flow model has these things called stocks, which we interpret as these things with quantity. There are flows that go from an upstream stock to a downstream stock. And there are links that say that the rate of flow depends of one the rate of one flow depends on the quantity in one stock. So this is not visible in this perspective, this screenshot of CatColab I showed before, but what is visible is sort of the content asserted within this frame. So we have a stock and flow model. On the left-hand side, we have this panel where we constructed this model, and on the right, we have this way of analyzing through, in this case, visual analysis, the model that is being described. So it says here, in this visual representation, the square boxes are stocks, the double arrows are flows, this blue arrow, single arrow, is an expression of a link. And so this particular thing here says that there is a flow from susceptible people to exposed people called exposure, and the rate of this flow depends on how many infectious people we have. Okay, so that's CatColab in a nutshell. How does it relate to these notions of this practice of abstraction that I'm advocating for in this talk, this accessible, responsive, pluralist practice of abstraction? So what do I mean first by these terms? I'll go through them one by one. By accessible, I mean a practice, these are terms applied to this practice of abstraction. And I say a practice of abstraction is accessible to a person or a community if it is clear what each frame is tracking and clear what it is not. So one thing I really want to highlight here is that accessibility is relative to a community, and different. And this is important as we talk about a practice of abstraction grounded in serving people, that these people are not invisible in these desiderata I'm naming here. So in terms of our running examples, for example, this impact evaluation frames what it means to be a good teacher. And it has this frame, it tracks things like test scores, and it tracks perhaps a little, but de-emphasizes. It doesn't really track things like community evaluations, qualitative reports about how people feel about your teaching practice. And this is perhaps clear to the designers of the system, but there is a question, is this clear to the teachers, and so on. And one way of making things accessible is by really trying to lay out formally what's going on. So to explicitly move from, the system might be represented in, a bunch of Python or something like that in code, which is only readable to a select group of people. And can you sort of either through, narrative journalism or through more sort of high-level declarative mathematical practice, just kind of describe the algorithm itself and what goes in and how it produces the results that it does. Formality plays a role that in this, and mathematicians use this sort of at great length. This is the core of our practice. What I want to point out is that even if you were to try and write sort of a sort of clear conceptual description of something like a teacher evaluation algorithm, as these algorithms get more and more complex, even a clear description is not necessarily accessible to the relevant community. And so as frames get more complex, mathematicians can contribute formality to increase accessibility, but we need to do this in a thoughtful way. And I want to give a particular example, a more specific example of the lessons we've learned at Topos about this. So again, formality is a tool that helps things be accessible, helps abstract systems be more accessible to mathematicians. And so what I've done here, I've put sort of 3 different presentations of a Petri net on the screen. One from Wikipedia, the bottom left one from a paper that was targeted at a more sort of general audience and was much more explicit in sort of its naming conventions, and the one from the right in a more technical paper that was aimed much more specifically at a research audience. And what I want to note here is, again, these are all basically describing the same structure, although we'll actually notice the differences, the visual differences between the 2 presentations below indicate actual slight differences in the nature of the Petri net, which are detectable to mathematicians or people that can easily sort of pass these diagrams quickly. The textual description is useful, but it's hard to quickly read at a glance, whereas the one on the bottom left, if you have some practice at reading these sort of schemas, becomes much quicker to read. You see a Petri net as a thing with places and transitions and these input arcs that run from places to transitions, so places go as input to transitions, places are outputs of transitions, and then you have links like for these stock flow diagrams that show how certain places affect the rate of transitions in sort of a positive or a negative way, as per, similar to the pattern for these causal loop diagrams. And on the left-hand side, you see one presentation. On the right-hand side, there's a slightly different presentation where we admit, instead of this sort of just positive and negative influence, just an abstract set A of ways of links can influence transitions. And there's this involution that keeps track of, that helps recover a bit of the structure of like the duality between a positive and negative structure. But anyway, so what I'm pointing out here is the way of sort of precisely describing a frame that creates more clarity about what is tracking and what is not, and thereby moving towards a notion of accessibility. Tim.
Yes, sorry to interrupt, Brendan, but I feel like well, I have a question, and I feel like maybe you would like a little more interactivity as well. So
yeah, please.
I wonder, because you're trying to link formality with accessibility, at least for mathematicians, as you explicitly say. And for me, a component of accessibility that isn't yet visible here is the ability to interject questions. Not to be very meta here, but yeah, sort of what we're doing right now. So I wonder if something in the representation, I suppose the one on my left, as I see it, so the one with the words, might make it easier to ask questions because it introduces words from which questions would arise. The other one, you might have questions, but you, as an audience member, but you may have a harder time articulating them because you don't know the terms to use necessarily. You'd have to point, let's say, or something. So I wonder if there's a way to formalize this access to question making, sense of like hooks or tools that the representation.
Yeah, this is an excellent point. Why don't I return to this in a couple of slides when I talk about the affordances we build into CatColab. So before I get there, I want to just very briefly whip through a story about. Perhaps this is less relevant to this organization, this audience. It is relevant to I think, a more mathematical audience. It was certainly, relevant to us as we were thinking about our work. So the thing I want to note is that as you really get into these abstract frames, although for the purposes of discussion, I've been presenting, fairly simple abstractions, fairly simple frames that can be understood just visually within the context of a few minutes in this talk, and then just referring in an informal way to these larger notions of, how we classify mortality, or how we teacher evaluation or social media recommendation or something like that. The abstractions we use as mathematicians get very complex. So we have we built up this framework for basically relating different abstract frames based on these notions of duck migrations. And so there's an account in the 70-page paper written in the language of polynomial functors by David Spivak and Richard Gardner and Aaron Fairbanks. It's implemented in this algebraic Julia library called Data Migrations by Evan Patterson and Chris Brown and some others. And what's interesting is that this is a highly expressive way to talk about migration, talk about relating different frames. So it's both required to do some really interesting things in, say, climate science, relating perspectives between, I don't know, an oceanographer and an atmospheric physicist. But it's also even required at fairly elementary levels, so say to relate Petri nets with links with causal loop diagrams and do this thing that is visually quite simple, but not usually expressible within more simpler notions of migration between schema. And the point I won't get into is that while this is implemented in a scientific computing library and available for use, even for non-mathematicians, you just have to write down your migration. But the language you write this down in is quite sophisticated to allow for the flexibility necessary to make these fairly sophisticated assertions about how one worldview relates to a different worldview. So things like conjunctive data migrations are well known from, or conjunctive queries at least are well known from practice in relational databases from language like schema. We sort of embody this in an entire sort of notion of migration from one schema to another instead of just pulling out a single table. And this is done through this notion of a functor from from what the schema to the category of diagrams, or the opposite of the category of diagrams in the other schema. There's a particular way we operationalize this. And to do this, you have to note that while you send objects to, so objects in D, so like, the notion of water to some diagrams, so some collection of objects and relationships in the schema C, you then have to send morphisms, that is the relationship between water and like plant growth or something, to then a relationship between two webs of relationships. And so this is represented by a natural transformation. But this is, again, just a conjunctive data migration. Then a duck migration, which is a disjoint union of conjunctive equation migrations, you actually have whole collections of these diagrams. So, water goes to some selection of, this aspect of ice and, rain or whatever in this other ontology, plus, this aspect of, I don't know, cloud cover and so on, plus, and so on and so on and so on. And then you have even more to keep track of as you talk about, well, then what does this, collection of webs of relationships, if you have some relationship, again, between water and plant life, you have these two collections of webs and relationships, you've got to track how you relate those two things. And you still have this complicated notion of a natural transformation, like represented in the bottom right, which is this sort of natural transformation between indexes of diagrams, which are themselves, involve natural transformations a level below. So the point is, I'm not trying to explain this to anyone in detail, whether you know sort of category theory or not, but the point is to just spend a couple of minutes belaboring how complex this is from a combinatorial perspective, even though it's conceptually quite simple when you have these layers of categorical structure built up over sort of years of experience. And so the question is, while this gives a really clear account of duck migrations for an experienced category theorist, it is essentially unusable or unreasonable to expect that people outside this tradition are motivated to learn how to use this and have the time and bandwidth and so on. And so it's not that the simple response of formality, kind of as you were saying, Ted, presenting formal objects to people does not inherently make things more accessible. But formality can provide a way of making things more accessible through computation. You have a basis for computationally embodying these abstractions. And then you can allow people to experience these abstractions internally by playing with them in certain ways. For example, by representing them, in a sort of a literate programming way, as you were talking about, Ted, writing down explicitly, names for things instead of just using these abstract variable names. You have a way of representing them, as you see here. You have a way of querying or doing some sort of data analysis, like automated reasoning of them, in this case, looking for loops. And then you have this way also of interrogating things by simulating and understanding the consequences of this, of the formal models that have been embodied. So this is a way we're seeing here, you can, in a live way, just play with, well, this is the SAR model. We had a diagram of it. Now let me plug in some values and see whether its behavior matches my intuition. And this is both a way of asking questions of the model, so you understand it better and have some agency to understand what it's tracking. And then moves into the next thing I'm going to talk about, which is responsiveness, which is that the sort of live collaborating features, and I won't demo here, but sort of editing features involving things like LLMs, provide agency over updating the frame as well, and asking questions not only of what the model means, but how to change the model. So this is again shading into this next point, which is that a practice of abstraction must not give people this accessibility, this ability to name the frame and understand what is being represented and what is not, but actually respond, ask this frame to respond to them. That is, modify the frame without undue cost, is my definition of responsive. And again, I want to note that this is again relative to the level of resources of a community. So we cannot expect everyone to, have all the time to really interrogate and unpack and go through, say, the political work of, I don't know, in this system of teacher evaluation. It's very, the way of modifying this impact evaluation was very heavy, and in fact, perhaps not accessible to the teachers impacted by this or the students. Questions were raised about the methodology, but in the end, the methodology remained in place. The particular, so that is to point out that there are a bunch of different angles that introduce sort of a lack of responsiveness to a practice of abstraction. And again, not all of them are mathematical in nature. In fact, most of them are not. But nonetheless, one thing that mathematicians can contribute is to pay attention to the flexibility of the systems from a formal point of view. So one driver of cost is a loss of content. To change the frame, you must often reconstruct content from scratch. So for an example of this, perhaps known to, these are drawn from a more technical community, but many of our climate models today, say used by the IPCC, are written in Fortran, and there are reasons why this language is hard to attain. It's an older language. It'd be useful to port them to a more modern language with higher level abstractions, say like Julia, or ultimately maybe even something like CatColab. But it's really non-trivial. So it's very expensive, and so we remain in these, different in this. So my frames here are Fortran versus Julia versus some other programming language, and we're just kind of stuck with the frame due to the cost of porting code from one language to another. Another example is that if you practice within a particular discipline, so for example, the discipline of macroeconomics, there are standard frames like these DSGs, the dynamic stochastic general equilibrium models, that years and years, decades of literature is built up with, and that is part of the way that the community speaks. And as the community has been exploring these modeling this particular modeling paradigm for the past few decades, it's also become clear that there are things that are not modeled, that has limitations, and people have certainly proposals for how to change these how to make modifications to this modeling framework to augment it or to capture different aspects of the world that are relevant to that specific macroeconomic modeling problems. But the challenge with that is that by modeling the frame, you lose the ability to connect with all of the previous models in the literature to build on the data analysis and the data sets that are being constructed over the previous decades. And so you sort of go out on a limb and you sort of lose connection with the conversation and all that is valuable in the existing conversation and community. So what I want to talk about here is explicit frames. Again, what can mathematicians contribute? What can category theorists contribute? It's talking about explicit frames as a tool for responsiveness. So on the right-hand side, we see two frames for causality. We see the simple frame, but then we might notice that as we're working in a particular case, that there are actually two meaningfully different notions of causal relationship, one that happens immediately and one that is delayed. And so in this very toy example here, I'm talking about, we have this example. I'm trying to have a frame for just analyzing my strawberry supplies. I really like strawberries. It's summer, it's great. You have, one way of obtaining strawberries is by going to the market. But then another way is by planting strawberry plants. But we see that that's a delayed effect, and that's not expressible. If we were just to encode this in the first frame, then we would lose the distinction and be able to reason about, what do we do now to get more strawberries. But what I can do is, so we saw the menu of sort of, the frame structures, how I can represent the world. So there was a certain set of affordances here for representation. That was too limiting. But then what I could do is I could migrate, and sort of it's invisible in the system, but I can migrate to a different frame where there are more notions of causal relationship, and then I can complete the picture that I want, and then use these analysis tools to reason about immediate feedback loops versus delayed feedback loops and so on. So that's a toy example to show how, being able to represent frames explicitly using, say, these double categorical tools also allows us to evolve the frame as we're getting experience about how the frame is valuable in the world. Um, okay. Finally, I want to introduce this notion of pluralism. And I say that a practice of abstraction is pluralist if multiple distinct frames can be used simultaneously in a coherent and productive way. Um, So again, going back to the beginning of what I was saying, a good frame is about directing attention to what matters and away from what doesn't. So a good frame is certainly relative to what a community cares about, but it's also relevant to its attentional bandwidth. And it's not the case that, we want to move towards this paradigm where we just try and construct everything. But like there are all these different distinctions we can make about the world. There are all these different relevant things to track. So let's just try and create some universal language which models the entire world. There are real gains, especially in terms of sort of analysis and reasoning, to saying let's let's have a distinct perspective, let's have a culture, and let's sort of agree to coherently restrict how we see the world from our particular local perspective. But then, of course, you you have these problems of either uh, having too many different frames and not not knowing which one to work with, or coming into conflict about which frames to use. But here again, making the frames explicit mathematically, again, that is not the tool that solves the issue, but it is a way of providing then further affordances that allow interoperation. So these notions of migration, say through this duck migration idea that I introduced earlier, but haven't demonstrated, is a way of saying, we can have these different frames. I, as a biochemist, can care deeply about the Petri net representation of what is going on, but you as a systems biologist, as caring about regulatory networks, can look at just the qualitative causal phenomena, and nonetheless we can maintain these incoherence as we work together, and sort of work from our own perspective, but nonetheless be modified and communicating through the same sort of system that studies whatever phenomenon we're jointly interested in. Or, for example, another example I want to give is this notion of version control, and structure of version control, where current version control systems tend to track, they do facilitate some notion of cooperation, some notion of joint editing of the same representation, the same code base, the same representation of the world. But they track sort of conflict, they track difference entirely on a syntactic level that says this string of characters is just different to this string of characters. And by reifying more of the structure to be legible to the machine, so again, we talked about CatColab as having this perspective where every machine readable statement has a precise mathematical semantics. And that means you can negotiate difference on the semantic level and highlight, not just that a difference has been made on these two lines of code, but there is a particular difference in the way that that different parties are modeling, the I don't know, water in the Pacific Ocean or something like that. That supports then semantic assistance with conflict resolution. Okay. So to conclude, I want to, my point here is that to not present solutions, but just to invite you all to join a conversation we're having at Topos about the practice of abstraction and the ways that these tools from category theory can support this practice that is accessible, responsive, and pluralist. And my final comment, other than a thank you to all the people who have helped contribute to this talk, is this. In this community, we often talk about providing better abstractions, but I think it's important not just to see abstractions themselves as the end goal, but to think about helping with a better practice of abstraction. So with that, thank you to everyone at Topos, and all the conversations I've had about this. It really is a wonderful community, a sort of neighborhood for thinking about these ideas. And I'll open up to questions.
Let's thank our speaker for his freaking talk. Thank you, Brendan. All right.
Thank you all for your time and for listening.
Yeah, and Brendan informed me that he has to leave in about 5 to 10 minutes. Brendan might have 5 to 10 minutes for questions. Is that right, Brendan?
Yeah.
Yeah, okay. So yeah, audience questions.
Thank you, Brendan. Let me ask one question just to move the discussion a little forward and encourage others to participate. I was wondering what you think the role of in specifically in the responsiveness portion of your talk. I found myself wondering what the role of essentially non-uniqueness, if you will, in the mapping to semantics is, as opposed to what is more traditional in other formulations of abstraction, more traditional formulations of abstraction, where essentially I find that one of the obstacles comes from a perceived kind of uniqueness to the meaning by the audience, so in what way can the framework that you are describing make more visible, more available, more transparent the plausible non-uniqueness of the meaning? To be explicit here, so that you have, so you see the degrees of freedom you still have available to you to play with in being responsive to the system.
Yeah, to me that comes a bit more under this notion of accessible, which is really providing people affordances to understand again what the abstraction is saying, what the frame is saying, what it's not, and so that involves giving people a way of really exploring, what assertions are actually being made by this your abstract system. And this comes through then being able to play with and experience the abstraction. It may be difficult at a first reading to understand, well, these are the, constraints, these are the declarations that have been made, these commitments that have been made, but it still retains these degrees of freedom, these aspects. As you say, that's often invisible, especially through perspective of mathematics that often aims at some sort of like universality and completeness and objectivity. And nonetheless, by sort of reifying these abstractions into systems that people can experience, you don't have to have this sort of reflective practice of reading an abstraction and thinking it through and finding those degrees of freedom, but you can expose sort of the different ways you could, for example, with a stock and flow model, an SAR model, there's a description of the patterns of transmission, but there are these variables left open in terms of rate constants or initialization conditions and so on. And by exposing them in that interface, people can play with them and realize, again, what you say, the sort of non-uniqueness of what is being expressed here. I hope that helps. I know Nikolai has his hand up too.
Yes, I have a question. Thank you very much indeed. I have basically two questions. Let me start with, more technical maybe. Roughly speaking, what did you, at least how do I understand your talk? You present some approach to ontological modeling, ontology modeling. Why not to use, for example, protege or any other tool? Very technical question.
Sorry, I didn't catch the other. I presented a thing for ontology.
Ontology modeling.
Ontology management.
Modeling.
Modeling, yes.
Yes.
And why not use?
Why not to use, for example, protege or any other similar tool? It is very technical question.
Yeah,
because you don't like it, it's okay for me. It's okay.
No, yeah, I think I would have to contrast against specific tools, but in general, what is provided by the double categorical perspective is, I guess it depends on the tool. There's a coherent meta language, right, that allows a lot of interoperability and migration between different ontologies. But then there's also the expressivity of the specific ontology languages themselves. So two things that are gained. One is a lot more logical structure than you have traditionally. And in fact, there's a paradigm for tuning the logical structure by moving between different doctrines of categorical logic to introduce as much structure as you need on, say, the classical sort of first order or higher order intuitionistic logic side, moving towards Topos theory, but also on, say, resource sensitive logic side, moving towards things like monodal categories, and those sort of different logical structures. So you've got a lot of room to play with the meta languages of the logical structure so that you can get at exactly the domain you want. And then the other interesting shift is that you're modeling. What you're doing is you're not describing just sort of a declarative, like an ontology that has sort of set theoretic models, but you're describing languages and logics themselves. By shifting to this double categorical layer, your models
I
of
got
a
it.
double theory are inherently categorical models. So they inherently have a notion of composition and hence are inherently linguistic. And that's not something I think that's afforded by really, at least in a serious way, by any previous tool.
May I ask another question?
Yeah, please.
Well, it will be more domain specific. Let us consider program languages. We have for program languages many semantics. Different operational, different denotational, different axiomatic semantics. How your approach can help or may help to have a general view on these semantics and their relations? Of course, very common situation is, for example, we have consistency or soundness or completeness theory. Yes, it's okay. But nevertheless, how to have some general view, how to abstract what is semantics of a programming language without concreticity, for example, operational semantics, axiomatic semantics, and so on.
Yeah, my hope is sort of to sidestep some of those questions. So one way that is interesting is that the modeling, categorical logic, its real sort of core contribution, I think, is to have a very clean separation between syntax and semantics. So we introduced this notion of like sort of this double categorical syntax, and then the semantic notions that I described here, at least in the slide, take semantics in the double categorical analogo set, which is I'm not sure whether I called it set or whether I called it span, but it's just with some notion of relation basically, as well as some notion of function. And but that choice of semantic category is a choice, and so you can switch to, say, probabilistic or non-deterministic semantic interpretation of these sort of abstract logical and algebraic and linguistic structures, and that provides some fluidity in notion of semantics, or helps us reason about the ways that one sort of program, what one sort of syntactic assertion can have different ways of being interpreted. But that doesn't quite get at, I think, your question, which is really about sort of the semantics of, to me, more imperative languages that have a lot of sort of operational unfolding. And this is where I made this comment that I sort of want to sidestep this. So this is an opinionated claim, but the perspective I want to take here is the core practice of modeling as it should be, sort of programming as it should be accessible to a wider population than software engineers and computer scientists, is really about world modeling. It's about declarative understanding of the world. And a lot of modeling languages, a lot of programming languages are actually tuned to modeling computational processes. That is how things are executed inside software. And those affordances are actually, they remain incredibly relevant to the people who are writing software. But they are not relevant to, I think, this class of people that we want to write software in the future. And that those things should be handled under the hood in, so you model a Petri net in the system, you are solving differential equations to get these curves that unpack the implications of those, but you're not writing in the system, at least as an initial user, the differential equation solvers themselves. You're calling some package that lives in, I don't know exactly where in this case, probably in the Rust ecosystem that has been written by someone else and is written in Rust and not in this higher level language. And so again, my contention is while these different notions of semantics are very interesting for certain people in the practice of computation who need to get into these details for reasons of correctness checking or efficiency and optimization, these details, it's sort of a feature of this approach that these details are not meant to be visible in this particular system, at least at a first glance. There's ways of making them visible to power users.
Thank you. Thank you indeed.
Thank you, Nikolai. Okay. Brendan, I will ask you the closing question. Oh, Dana has a question?
No.
Okay. So since we are running out of time, I would ask the closing question, Brendan. So if people want to play with CatColab and find more information, what are the resources where they can find it?
Great question. Thank you. So it's catcolab.org is where you can access, is the place to go. So CatColab.org. And from there, you'll find, what will you find? You'll find a live instance of that. So you can create an account, say using your Google login, and then have some library of models to play with yourself. You can find out all the documentation and tutorials. You can find the link to the Zulip and join the Zulip and communicate with people there. You can go to GitHub and you can access the source code itself and participate in looking at issues and seeing what you can, understanding what's going on or seeing what you can contribute. So lots of things there. catcolab.org.
That's awesome. And does it have the documentation as well, right?
It does. These things, this is a project that has just begun in about in approximately the last year, and we've got a long way to go. But the documentation is underway, and it will improve in the months and years to come.
Okay. So since this is, I understand this is an open source project, is it, sir?
Yeah.
And can people contribute to it for people?
Yes, please. Yeah. If you'd like to, I mean, you can see, what's happening on GitHub. You can see all the open issues. You can submit a pull request. But of course, the best way to participate in a project is also to connect in a live way with the people doing it. So if you join the Zulip, that's a Slack-like or Discord-like chat room where you can just speak to the lead developers and ask questions, see what needs to be done.
Awesome. Thank you, Brendan.
Cool. Thanks, Priya, and thanks, everyone. It's been wonderful chatting with you all.
Great. Let's thank our speaker again.
Thank you, Brendan.
Thank you, Brendan. And we'll see everyone next, in September. Thank you.
Cool.
Bye.